Hi everyone, how are you? Welcome back Murari Maths online classes. Today we discuss about determinants, Jeemains previous year questions. Okay, now explain first question. In the statement matrix A given, as well as one condition A into adjoint of A is equal to A into transpose of A, then find out 5A plus B. So what is the given condition? A into adjoint of A is equal to A into transpose of A. Here by using left cancellation law, here A get cancelled. What we get here? Adjoint of A is equal to transpose of A. Okay, what about adjoint of A? Adjoint of A is nothing but transpose of cofactor matrix. Transpose of cofactor matrix. Okay, first find out cofactor matrix, then its transpose is adjoint of A. That is the procedure. So one direct method is there. A is equal to 5A minus B 3 2. So adjoint of A is equal to, first we should interchange principal diagonal elements. Five A, 2 can be written as 2 5A. Other diagonals multiply with one negative sign. Here minus B, here plus 3 there. Okay, we will write B minus 3. This is called adjoint of A. What is the adjoint of A shortcut method? First, we should interchange principal diagonal elements. Then after, other diagonals multiply with one negative sign. Okay, now adjoint of A place and write this value 2B minus 3 5A. Transpose of A from statement matrix A given, then its transpose is 5A 3 place and right. First, by what is the definition of transpose? By changing its rows into columns or columns into rows. Okay, first column will be changed first row in transpose. Here minus B2. Here write minus B2 in second row. Let us observe these two matrices. These two matrices are equal matrices. Equal matrices. Now equating corresponding elements, what we get? 5A is equal to 2 here. 5A is equal to 2, B value 3. But what is required here? From statement required is 5A plus B. So 5A plus B is equal to, here 2 plus 3 value, how much value? 5 answer. Okay, now explain next question. In the statement, matrix P given is the adjoint of 3 by 3 matrix. Adjoint of 3 by 3 matrix A. As well as that of A value 4. Then find out alpha value. So here P is the, here P is the adjoint of 3 by 3 matrix. P is equal to adjoint of A. Now taking delta on both sides. Why? Because in the statement delta of A value given 4. So delta P is equal to delta of adjoint of A. So if from statement P matrix is given, delta P how much value? 1 alpha 3, 1 3 3, 2 4 4. A plus minus plus. So plus 1 into how much? Here 1 present in first row, first column. After deleting first row, first column, what we this delta value is 0. 12 minus 12. Minus alpha times of, here alpha present in first row, second column. After deleting first row, second column, what we get? 1 into 4, 4 minus 6 minus 2. plus 3 into here this value 4 minus 6 2. So here what we get here 4 minus 6 minus 2. Sorry. Here what we get here 2 alpha minus 6. 2 alpha minus 6. So that p value 2 alpha minus 6 is equal to that of adjoint of A. We have one formula that A power n minus 1, where n is order of square matrix. Here order of square matrix, how much value? 3. So n place and write 3, n is equal to 3. That A value from statement 4 given. So 2 alpha minus 6 is equal to 2 alpha minus 6 is equal to that A value here 4, 4 to the power 3 minus 1. 2 alpha is equal to here 4 square 16 plus 6. 2 alpha is equal 22. Alpha we get 11. What is answer? 11 answer. Okay, now explain next question. In the statement matrix A given, adjoint of 3A square plus 12A. This is required. First we have to find A square value. A square is equal to A into A, right? A value from statement A given 2 minus 3 minus 4 1, right? 2 minus 3 minus 4 1. Now we should multiply. What we get here? First row multiply with first column 16. First row second column minus 9. Second row first column minus 12. Second row second column. Second row second column. After multiplication we get 13. This is A square. Okay, then after we should find 3A square. Let us find 3A square plus 12A. 3 times of A square plus 12 times of A matrix. What we get here? Here 3 multiplied to all as well as 12 multiplied to this second matrix. We get total value is 72 minus 63 minus 84 51. This is 3A square plus 12A value. But what is required here? Adjoint of 3A square plus 12A. Adjoint of 3A square plus 12A. So adjoint of 3A square plus 12A value we have got it. 72 minus 63 minus 84 51. What we get here? So what is adjoint of A? Adjoint of A is nothing but transpose of cofactor matrix. So easy method. Here easy method is first we should interchange principal diagonal elements. 72 51 will be right 51 72 in principal diagonal. Other diagonals multiply with 1 minus 1. Here is 63 minus 63 minus 84, it will become 63 84. This is nothing but adjoint of A. This is shortcut method. So what is the formula? Adjoint of ABCD is equal to D minus B minus C A. This is adjoint of 2 by 2. Okay, now explain next statement. In the statement, one matrix A given as well as B is equal to adjoint of A, C is equal to 3A. 3 times of matrix A given. Then find out that of adjoint of B by that C. What is required here? Required is that of adjoint of B by that C is equal to that of adjoint of, here B matrix place in right, adjoint of A by that C. That C value from statement given, C value how much value? 3A, that of 3A. Okay, we have one formula. Det of adjoint A is equal to, what is the formula? Det A power n minus 1 whole square. If three adjoints are there, what is the formula? Det A power n minus 1 whole cube. Okay, right, first formula det A power n minus 1 whole square. So we have one more denominator, det of 3a. Det of Ka, one more formula is there. Det of Ka is equal to k to the power n into det A. Here k to the power n into det A. But here k value, how much value here? K value 3, n value 3. 3 to the power 3. Here k value 3, n is order of A. This is also 3. So det A power n value, how much value here? N value 3 minus 1 whole square. It will become 4 by 27 into det A. One det A value get cancelled here. Det A to the power 4 here there. Det A whole cube by 27. First, from statement matrix A given, A is equal to 1, 1, 2, 1, 3, 4, 1 minus 1, 3. Now find out det of A. The det of A is equal to det symbol. This is the plus minus plus. So after det simplification, we get det value, det of A value 6. Here 6 cube. 6 cube by 27. 6 cube is nothing but 216 by 27. 27 1j, 27 8j get cancelled. What is the answer? 8. Okay, now explain next question. Here AB, two invertible matrices of order 3 by 3. Two conditions are given. Det of AB A transpose is equal to 8. Det of AB inverse is equal to 8. Then find out det of B A inverse B transpose. So what is the statement here? Det of AB A transpose is equal to 8. So this we have one formula. Det of ABC is equal to det A into det B into det C. So det PQ is equal to det P into det Q. Okay, now we should apply first formula, det of ABC. Det of A into det of B into det of C. We get here det of A into det of B into det of transpose of A is equal to 8. But here det of transpose of A, det of A both are equal. Okay, I will give one example. Let us take det of A is equal to det of 1, 2, 3, 4. How much this det value? 4 minus 6 minus 2. Det of transpose of A, how much value? Its transpose is 1, 3, 2, 4. This det also same minus 2. So det of A, det of transpose of A both are equal. So that implies det of A into det of B into transpose of A value is nothing but det of A. Okay, here let us take this is equation 1. The second equation, what is given here? Det of AB inverse is equal to 8. Is nothing but det of A into det B inverse is equal to 8. Det of A into det B inverse is nothing but det B whole inverse. Okay, we have one formula. Det of P inverse is equal to det P whole inverse. Okay, det of A into det B inverse. Det B is one of the constant. Constant power minus 1 is nothing but 1 by constant. Is equal to 8. This is second equation. Okay, now multiplying equation 1 and equation 2. Main our target det A, det B values. Okay, now multiplying equation 1 and equation 2. What we get here? Det A into det B into det A into here det of A by det of B is equal to 8 into 8. Here det B get cancelled. What we get here? Det A into det A into det A whole cube is equal to 8 into 8, 64 can be written as 4 cube. What we get if bases equal, if powers are equal, bases also equal, det A is equal, we get 4. Delta A value, how much value we have got it? 4. So delta A value substitute in second equation or first equation, we get B value. We get delta B value. From second equation, delta of A by delta of B is equal to 8. Here delta A value, how much value? 4 by delta B unknown value is equal to 8. So delta B we get 4 by 8. 4 by 8 is nothing but 1 by 8. But what is required here? Required is, this is required. Delta of B A inverse B transpose. Delta of B A inverse transpose of B is nothing but delta B into delta A inverse into delta transpose of B. Delta B into delta of A inverse is nothing but delta A whole inverse. Delta B transpose. Delta B transpose of delta of transpose of B, delta of B both are equal. Here delta B value already we have got it 1 by 2. So delta B into delta B by delta of A. The delta B value 1 by 2 into 1 by 2 by delta of A value 4. What we get here? 2 2 is 4, 4 4 is 16. 1 by 16 answer. Okay, now explain next question. In this statement, one continuous product is given. Data of matrix of 1101 into 1201 into 1301 into and so on 1 n minus 101 is equal to 17801. Then find out inverse of this matrix. Inverse of 1 n 01. First find out n value. How to find n value? First find out all matrices product. First find out this. First let us take first two matrices. 1101 into 1201. What we get here? First row multiply with first column, we get 1. First row, second column, 1 into 2, 1 into 1, 1 plus 2. Second row, first column, 0. Second row, second column, it will be 1. Okay, next, multiply with 1301. Continuation. 1, 3, 0, 1 into here 1301 into 1301. What we get here? Here first row multiply with first column, what we get? 1. First row, second column. First row, second column, 1 into 3, 3 into 1, 6. 6 can be written as 1 plus 2 plus 3. Second row, first column, 0. Second row, second column, 1. Like up to how many matrices are there? N minus 1 matrices are there. So after product, it will becomes 1, 1 plus 2 plus 3 plus and so on, n minus 1, 0, 1 is equal to 17801. Okay, now these two matrices are equal matrices, corresponding elements are equal. Here A12, first row, second column element, here 1 plus 2 plus 3 plus and so on, n minus 1, here 78 is there. Now equating 1 plus 2 plus 3 plus and so on, n minus 1 is equal 78. Here, sum of first n minus 1 natural numbers. The first n natural numbers formula is n into n plus 1 by 2. But n plus what is there here? N minus 1 is there. N minus 1 into here n place and write n minus 1. N minus 1 plus 1 by 2. What we get here? N into n minus 1 by 2. N into n minus 1 by 2 is equal 78. So after simplification, we get n values. n into n minus 1 by 2 is equal to 78. N into n minus 1 is equal to 78 into 2, 156. Okay, after multiplication, n square minus n minus 156 is equal to 0. Factors are n square minus 13n plus 12n minus 156 is equal to 0. They take n common, n minus 13. Here at 12 common, here n minus 13. N minus 13 also I take common. N plus 12. So n value we get 13 and n is equal to minus 12. So n is equal to minus 12 not possible. N is equal to 13. If n is equal to 13, what is the required here? 1 n 0 1 inverse of the matrix 1 n 0 1. Let us take A is equal to 1 n 0 1 1 3 0 1. N place in 13, so 13. 1 13 0 1. So what is required here? Required is A inverse. A inverse formula is 1 by det A into adjoint of A. 1 by det A. Det A value, how much value? AD minus BC is 1. 1 by 1 into adjoint of A. Adjoint of A easy method. Now we should interchange principal diagonal elements. Here 1 13 0 1. Principal elements we should interchange here. 1 1. Other diagonals multiply with the negative sign, minus 13 0. So this is the answer. What is the answer? 1 minus 13 0 1. Okay, now explain next statement. In the statement, A square minus A plus I is equal to O. Then the inverse of the matrix A. How to find? In statement, A square minus A plus I is equal to O given. So what is our required? A inverse is required. So now we should multiply A inverse on both sides. So pre-multiply or post-multiply A inverse on both sides. So A inverse into A square minus A inverse into A plus A inverse into I is equal to A inverse into O. So A inverse into A square. So A inverse into A, right? A inverse into A, how much value? I. A inverse into A is equal to I. IA. A inverse into A, again write here I. A inverse into I is equal to A inverse. Any matrix into unit matrix is equal to same matrix. So here write A inverse is equal to null matrix into anything, null matrix. So what is here I into A? How much value I into A? I into A is nothing but A minus I is equal I plus A inverse is equal to O. So here required is A inverse. A inverse is equal to here minus I plus A. Sending right side, what we get? I minus A. This is the answer. Okay, now explain a statement. In the statement, matrix A as well as unit matrix given, then find out 10 A inverse. So all options combinations are in terms of A or I there. Okay, now this kind of problems by using characteristic equation formula. Characteristic equation of the matrix A. Okay, we have one formula modular det of A minus lambda I is equal to 0. Det of A minus lambda I is equal to 0. Det of A matrix here, right? 2294 minus lambda times of unit matrix, right? 1001 is equal to 0. Okay, now do subtraction these two matrices. 2 minus lambda. Next 2 minus 0. 2 minus 0 is 2. 9 minus 0 is 9. 4 minus lambda. After that simplification, what we get here? 2 minus lambda into AD minus BC formula, right? 2 minus lambda into 4 minus lambda is equal to minus 18 is equal to 0. Okay, we get here lambda square minus 6 lambda minus 10 is equal to 0. But each square matrix satisfies its own characteristic equation. Okay, here lambda place in right a square minus 6a minus 10. 10 is nothing but 10 into I. Okay, now what is required here? A inverse is required. Now pre-multiply A inverse on both sides. What we get here? A inverse A square minus 6 into A inverse into A minus 10 times of A inverse into I is equal to O. So A inverse into A square here, one A get cancelled, A minus 6 into A inverse into A is nothing but unit matrix I minus 10 times of A inverse into unit matrix is A inverse. Okay, minus 10 A inverse sending right side. What we get here? 10 A inverse is equal to A minus 6A. A minus 6I. A minus 6I. Which option is correct? Second option is correct. Okay, in the statement, A 3 by 3 matrix given, adjoint of A value as well as B matrix is given. What is B given here? Adjoint of A. The lambda value here, lambda value that of A, mu value that of transpose of B inverse, then find out ordered pairs modulus of lambda comma mu. So from statement, adjoint of A is 2 minus 1 plus 1 minus 1 0 2 1 minus 2 minus 1 given. Okay, first find out delta of A value. How to find delta of A? Now taking delta on both sides. Now taking delta on both sides. What we get here? Delta of adjoint of A is equal to delta of 2 minus 1 1 minus 1 0 2 1 minus 2 minus 1. It will becomes here plus minus plus. After simplification we get 9. Delta of adjoint A, we have one formula delta A power n minus 1. But n value here, how much value? N value 3 by 3 square matrix is given, n is equal to 3. Is equal to 9. Delta A power n minus 1. 3 minus 1, it will becomes delta A whole square is equal to 9. Delta A we get plus or minus 3. Delta A value plus or minus 3. But delta A value from statement, what is given? Mu, lambda. Lambda is equal to delta of A is equal to plus or minus 3. But required is here modulus of lambda is required. Modulus of lambda is equal to modulus of plus or minus 3. What we get here? 3 only. Then after find out mu value. But mu, what is the mu given? Mu is equal to transpose of B inverse. Delta of transpose of B inverse. Okay, we have one formula delta of P is equal delta of transpose of P. So delta of transpose of B inverse is nothing but delta of B inverse. Delta of B inverse is det B whole inverse. Det B whole inverse is nothing but 1 by det B. First find out det B value. From B value, from statement B matrix, what is given? Adjoint of A. Now taking delta on both sides, det B is equal to delta of adjoint of A. What we get here? Delta of adjoint of A is nothing but delta A power n minus 1 whole square. We have one formula. But delta A value here, what we have got it plus or minus 3. Plus or minus 3 times of plus or minus 3 power n minus 1 whole square. But n value here, how much value? 3. 3 minus 1 whole square value 4. What we get here? 81. 3 to the power 4. Okay, therefore mu is equal to 1 by that b value we have got it 81, 1 by 81. So what is required? Final required is modulus of lambda comma mu. This is nothing but modulus of lambda we have got 3, 3 comma 1 by 81. Okay, now explain next statement. In the statement, A be a 3 by 3 real matrix if det of 2 times of adjoint of 2 times of adjoint of adjoint of 2A is equal to 2 to the power 41, then find out det of A square. From statement, what is given here? Det of 2 adjoint of 2 adjoint of adjoint of 2A. Now find out 2 adjoint of 2 adjoint of 2A. Okay, we have one formula. Adjoint of Ka. Adjoint of Ka is equal K to the power n minus 1 into adjoint of A. Okay, here first find out this value, after that taking det on both sides. So 2 times of adjoint of 2 times of adjoint of 2A, we have formula that adjoint of Ka is K to the power n minus 1 into adjoint of A. Here 2 to the power n value, how much value here? N is equal to, this is a 3 by 3 square matrix. N is equal to 3. 2 power 3 minus 1 into adjoint of A. So 2 times of adjoint of 2 times of adjoint of this value 4. 4 times of adjoint of A. Okay, again we should write same formula. What is the formula here? Adjoint of 4 times of adjoint of A. Here K value 4. Here A place in adjoint of A there. This is A. So we have adjoint of Ka, one formula K to the power n minus 1 into adjoint of A. 2 times of adjoint of 2 into, what is the formula? K to the power n minus 1. 4 to the power n minus 1. 3 minus 1. Adjoint of A. Adjoint of A is nothing but one of the matrix. Let us take A here. Okay, this value, how much value? 4 square into 2, 32. 2 times of adjoint of 32 times of adjoint of A. Adjoint of A. Here, adjoint of A, let us take A. Here, K value, how much value? 32. Now we should apply same formula again. 2 times of, what is the formula? K to the power n minus 1. 32 to the power n minus 1. 32 to the power n minus 1 means 3 minus 1 into adjoint of A. Is 32 whole square. 32 whole square into 2. 2 into 32 is nothing but 2 to the power 5. 2 to the power 5 whole square is 2 to the power 10 into adjoint of A. Okay, now this continuation 2 to the power 11 into how many adjoints are there? Adjoint of A. But statement, what is given? Det of this total value 2 to the power 11 into adjoint of A is equal to how much value? 2 to the power 41 given. Okay, we have one formula, det of Ka is equal to K to the power n into det A. Here, 2 to here, K value here, 2 to the power 11. This total is A. Now applying this formula, 2 to the power 11 whole cube. Why? Because your n value, how much value? 3. 2 to the power 11 whole cube into det of adjoint of adjoint of adjoint A is equal to 2 to the power 41. So this will be 2 to the power 33 into adjoint of adjoint of adjoint of A is nothing but det A power n minus 1 whole cube is equal to 2 to the power 41 can be written as 2 to the power 33 into 2 to the power 8. 2 to the power 33 get cancelled. So but det A value, this is required det A n value, how much value? 3, 3 minus 1 whole cube. 3 minus 1 is 2, 2 cube is 8 is equal to 2 to the power 8. Therefore, that A is equal plus or minus 2. What is required here? Required is that A whole square. That A square. That A square is nothing but that A whole square is nothing but plus or minus 2 whole square. We get that A value, already we have got it plus or minus 2. Plus or minus 2 whole square is equal to how much value? 4 answer. Thank you for watching. Remaining questions I will explain on next class.